So now that we've seen what existential quantifiers, existential statements are, and what universal statements are, we like to be able to evaluate statements and arguments using those qualifiers, just like we did with things like conjunctions, disjunctions, conditional statements, and those other kinds of logical operators. Now, to do that, we're going to take a different approach, and it's an approach that is very visual. We're going to create these things that are called Euler diagrams. And the way we do this is kind of based on thinking about the groups that are mentioned in the statement and how they relate to each other. For example, looking at this first statement, all firemen are brave. We have two groups in this statement. We have firemen and we have brave people. So sometimes we have to add a little bit, right, just to turn this into a group of physical objects. So we're going to kind of qualify this here, brave people. And the way these Euler diagrams work is I'm going to draw one circle for each group. And what's really significant is where these circles are positioned with respect to each other, right? So first, think about what this means, right? All firemen are brave, or brave people. That means if I draw a circle here and label this one brave people, all firemen are going to be in that circle, right? So I would draw another circle here and label this one firemen. And that's how I would illustrate, right, an all relationship. All right, now look at this second one. Now I've got two groups here again. This time I have dogs and reptiles. So again, I'm going to have two circles. And the question is, how do they relate to each other? Well, because no dogs or reptiles, that's telling me that there are going to be no dogs in the reptile circle. All right, so I'm going to draw my reptiles circle, and I'm going to draw my dogs circle. And you notice that the two don't overlap, right? None of the dogs are also in the reptile category. Right, so finally, we have some, right? Some cars are green. So what are my objects here? Well, here, one of them is obviously going to be cars. And the other one, green, this is another one I'm going to have to qualify a little bit. I'm going to say green things, right? So now I know that some cars are going to be in the green circle, but some aren't. Right, so that's how I'm going to draw this. I'm going to draw a circle for green things, and another circle here for cars. You notice that there is some overlap, but one is not completely contained in each other. So these are going to be the three cases, three types of scenarios we're going to see as we continue on and start trying to apply these to arguments. Right, now there is one more thing we need to consider, and you notice I'm kind of playing off of our previous two scenarios here, right? This first one, all firemen are brave. So let me kind of duplicate what I had before, right? We've got brave people, and I'm going to put firemen inside it. Now, the second sentence, John, you see, now this is a little different. John is not a group, right? John is an individual. Groups are illustrated with circles. Individuals are illustrated using dots or points. So I'm going to locate John. I'm going to put a dot here for him, and I'm going to put that inside the fireman circle. So that's how I would locate an individual person within the diagram. All right, so let's try this one here. right? Again, we're doing dogs and reptiles here, like we did on the previous slide. So let me kind of duplicate that. Now, Mark's pet is a turtle. Turtles are reptiles, right? So I'm going to put a dot for Mark's pet in the reptiles circle. So let's see how we can put these things together and use them to verify arguments. So again, I'm kind of playing off of the same concepts here, right? We have all firemen are brave, so I'm going to start with brave people, kind of playing on these existing diagram. Then I'm going to put one here for firemen. Then I'm going to locate John. John is a fireman, so I'm going to put John here in the fireman circle. Now, my question is to confirm or deny kind of this argument, to determine if it's valid or invalid. Does John have to be brave? Well, yeah, there's no place I could put John in that fireman circle that wouldn't have also located him in the brave circle, right? Therefore, John must also be brave, and this is a valid argument. Right, so let's try another one. You can try this if you like, right? But you can pause, try this one on your own, then see how I do it. So again, I'm playing off of one that we've seen already. We have green things, and I know that some cars are green, so I'm going to put cars here because that's how we do sum, right? They overlap. John has a car, and the question is John's car green? Well, what you have to remember, what this is asking is, does John's car have to be green? Based on the two assumptions above the line here, is John's car being green the only possible conclusion? And it isn't, right? I could, maybe John's car goes down here, in which is outside of the green circle. So no, these two things, these two statements, do not mandate that John's car must be green. So this is an invalid argument. All right, let's try one more here. Now this one is a little bigger, right? A little more complicated, but that's okay. We're going to follow the exact same process. So let's see. First, I'm talking about tall people, and again, I'm going to kind of add a little something here to give this a noun, wealthy people. Right, so I know that all tall people are wealthy. Okay, so I'm going to draw the wealthy circle, wealthy people, and tall people, all of them fall into that category. Right, remember, that's how we do in all. All wealthy people are admired. Okay, so again, this is an all, right? So the wealthy people is going to be completely contained in, okay, not very artistic, right? Not a perfect circle, but you get the idea, right? These are admired people. Some basketball players are not admired. Okay, so this is a sum, right? So the basketball players circle and the admired circle are going to overlap, but there are going to be some basketball players who are outside of the admired circle, right? Which will put them in the not admired category. Now notice how I do this, and again, I'm going to have to depart from a real pure circle here, but I'm going to draw this so that the basketball players circle overlaps the tall people and wealthy people circles, because the statement didn't give me any reason to believe they shouldn't. And I want to include as many possibilities as possible within the limitations of the statements. Okay, so some basketball players are not tall. Well, that's true, right? Everybody in here, those would be basketball players who are wealthy, right? They're not tall. And here we've got basketball players who are admired. Anybody in there would be not tall. So yes, it is possible, right? Some just says, not necessarily all of them, but at least one are not tall. So this is a valid argument. So this brings us to the end of our discussion of logic, right? But we are going to continue to use this. In the next chapter, we're going to start talking about number theory. Number theory is a really interesting topic. It's a very deep topic, a topic with a lot of unanswered questions, a lot of very active research going on there. But at the same time, it's a topic that has some statements that are very straightforward, very understandable, even at a beginning level. So that's going to give us some great opportunities to practice using these logical methods as tools to prove mathematical statements.